I'm going to introduce to you guys Srdjan Vranac, who is here to talk about Gearman. He has experience with building distributed systems, and in his words, he has experience in writing really bad code, which performs excellently. Apart from writing bad code, he really knows how he should write good code so that this way he knows how to break it afterwards. And applause for Srdjan Vranac, please.
Can you hear me well? Okay, excellent. So, welcome to the talk. My name is Srdjan Vranac. I'm from Novi Sad. I run a small company and a team. And like it says here, I'm a business owner, developer. I'm wrangling elephants and pythons on a daily basis. I'm very interested in process automation, continuous integration and delivery, writing unit tests and good code. Unfortunately, that doesn't happen often. Yeah. So I'm here to talk to you about Gearman. First, word of warning. I'm partial to using images, and I do believe that they drive the message through better. And I don't have a lot of slides, a lot of code in my slides. Also, during this talk, the speaker, meaning me, might exhibit some race conditions with words, lag in thoughts, occasional seg fault, and OM. And this is not a result of stage fright or bad preparedness or party last night. This is basically carefully choreographed act that should not be tried at home. So, story time. Imagine that your client has hired you to build an application that has this interesting feature that scrapes information from a couple of websites, updates information in the database, and that needs to be done every 12 hours. So you build your thing, it works. You figure that you can use cron job for it, and it's really nice. It's running. You passed from testing to production. They put in some couple of thousand products in it. Everybody's happy. Everything works. And suddenly, on one stand-up, the CTO appears and says, hey, you guys did a really good job. We are going to now switch to using our main database, and you're starting to look like, what? This wasn't the main database? Yeah, this wasn't our main database. So what's the difference? Well, in this database, we have like 5,000 products. Okay, so how worse can it be? And the main database has 30 million products. What? Okay, things start to fall apart. Cron jobs won't work. So you still have the same premise, 12 hours to complete the task. Only the number of products has increased insanely. So you do a bit of a math, and you see that for 30 million products to be parsed in 12 hours, you need to do 2.5 million products an hour, which boils down to 695 products per second. Or that's roughly 600 nodes that will process one product in 1.1 second under optimal conditions. Yeah, cron's not going to cut it anymore. So now, you go back to the management. Imagine the situation where you're actually trying to ask them for 600 machines. Yeah, no, not going to happen. Or how you gonna set up 600 cron jobs to do this in a sane way? No, not gonna happen. And this is basically what happened to me. This story is a good example of async processing. Does anybody here not know what async processing is? So everybody knows. Oh, cool. So basically, it's a neat little pattern. So imagine that you need 10, 15, 20 records from the database. You send out requests, you move along. It's not blocking. And once upon a time, the data will come back, and you will get, the callbacks will be executed, and data will be processed. But since nothing is blocked, everything worked from the get-go, and that was great. Also, the best way to build asynchronous processing and a synchronous system would be to use messaging in queues. In essence, it is always a simple system where a process issues a message, Somewhere there is another process that listens for that message, it understands it, it processes it, and so on. With this, you can do a lot of things. In a similar way, you can actually build a queue system where you have one process issuing the messages to a queue that's, let's call it another process, and we have a third worker process that's constantly pinging the queue process for next message to do something with it and process it, and so on and on and on and on. Examples of these systems are RabbitMQ, ZeroMQ, Gearman, Beanstalk, Rescue. I think that's about all. I've been exposed so far to Gearman and RabbitMQ. And we come to the subject of our talk, which will be very short. So, what's Gearman? Gearman is a tool that was originally written in Perl, that was later rewritten in C. It has an excellent low-level integration with PHP and an awesome manual on a PHP site, so you can read it there. And Gearman also is an anagram of a manager because it dispatches the jobs but does not do anything useful by itself. True story. Thank you. So, how does it work? So, we have a web server, we have a Gearman server, and we have workers. Gearman server and workers can be on the same machine, don't have to be, it really doesn't matter. The web server issues a job, I need this done, to the Gearman job server. And the Gearman workers receive those messages and process them. So when we're talking about those 600 nodes, imagine that you have 600 Gearman workers processing it. They can do that when you have a nice little marshalling interface that you can collect all your jobs and put it in, and they will just come around and do what you need. So it's a really nice pattern, and it helps do a lot of nice things. To set up Gearman on your machines, basically if you have Red Hat or Fedora or Debian, you just use your package manager to get Gearman-D or Gearman job server. You need your PHP extension from Packle, add it into your PHP extensions file, and that's about it. You now have Gearman running. Gearman has tasks and jobs. So a task is a request for or communication between the client and the job server. A task is usually communication about the job. Task might be, please run this job, or what is the status of that job, and a job is something that worker does, continuously waiting on the job server to tell him what to do and with what arguments. This is basically the most important piece of code in any Gearman project. Before I explain what it actually does, let me be very clear about one thing. I love PHP. I live from it daily. I get paid for building stuff with it, but PHP is not good in long-running processes. Any resources that it ever gets will never be freed until the process is killed. That's the way it is. You can abuse it or don't. But when using Gearman and workers, you can assume that your worker script will be running for a long time, and if it is in any way resource intensive, it is not a matter of when, but if it will fail and bring your whole server with it. This piece of code basically sets a timeout for 2 hours, and there is this nice loop that if return code from the worker is Gearman timeout, meaning that the job server said, like, there's nothing else for you to do, you exit it. And this is basically the same way to keep your servers running for a long time. In our case, when we launched the V1 version of our product with Gearman, we had basically anywhere between 48 and 72 hours of running time before it crashed. And it crashed in such a way that the server actually needed, like the instance needed to be rebooted. You couldn't log into it, nothing. And then when you go back into logs, you see, oh, I'm going crazy. And now we get to Gearman docs. Oh, this really happens. I mean, it's insane. Every time you try to look for something for Gearman, he actually says, are you sure you're not looking for something about the Germans? How do you stop a German? You don't. Fuck. Gearman, on Gearman's side, the documentation is really brief because it's really a simple process, and like Davey said, like the source code of Gearman can be understood in like a couple of minutes. It's really easy and simple, and on PHPNet manual, you have a really good source of description of all the functions that you need, and basically the code that I just showed was the only part that was hidden in comments. And now we have demons everywhere because our workers will like exit because of timeout, jobs, no jobs available, some exception, whatever. And they need to be kept running constantly, like 24/7 without interruption, or at least with minimal interruption, to be more precise. So what you do with them, you have to use a daemon, basically, to keep them running. Your options are far and wide, but two of the most popular are Supervisor and Upstart. Supervisor is a Python project, basically a daemon that you send a configuration script to, and it monitors your processes in the number of them that you need, so 1, 10, 15,000, it doesn't matter, and monitors them if the number of them is correct. It keeps them. If the number is less than required, it spawns on new instances, and that's the way it does. Upstart basically is Canonical's take on Supervisor that is integrated in Ubuntu. Both are well documented, both are straightforward to use. Well, that was quick. That's the Gearman part. Yeah. Oh, no. The fun is about to start. Seriously. So, first thing is running order. Gearman queue is FIFO, meaning first in, first out. But if you have more than one worker running, you have no reliable order of execution because of different things happening in the system. One worker will be faster, the other one will be slower. So you shouldn't really ever count on the order of execution of Gearman jobs. And this allows you to distribute the workers because some will be slow, some will be fast, but eventually everything will be processed. Then you have reliability. Such a funny word. The assumption is that a job will get enqueued and it will be processed sometimes, but you can't reliably know when. Another problem is that when a worker fails, job will obviously fail, but the issuing server has moved on and to do other things while you're thinking you issued 5 jobs. In reality, one failed and things don't work anymore. For example, if you are uploading an image to S3 and in an HTTP request and the request fails, from within the worker you should then requeue the task to be executed again sometimes. And that is basically how you start building reliability into unreliable systems. Queue systems are unreliable by design, and that is what allows them to be scaled. Now we have data. So we have the same setup from before, and at the end you have a DB server. So basically, worker gets a job, whatever it needs to be done, and then pushes the results into a DB server. So what happens if database server fails? Well, of course, everything will fail because it is a single point of failure of your system, and that happens that tend to happen a lot in projects. So what can you actually do about it? Well, the first thing is location of your data. It is very important. And actually distributing the data to different locations tends to solve that problem. So what it means is if you have a Gearman job that you just pass some ID to it, and then it needs to go into the database and read all the data and execute it and send it back to the data, if your database fails, you will not have a good time. What is a better approach to do it is to send all the pertinent information for a job to be done to a worker. So anything you need, you create a payload, send it into a worker, it will do its thing. If the database server fails, he will just be able to requeue the whole job again with all the parameters you had, and it will be looping around until the database server comes back up, and you will not be missing too much data apart from downtime. Or another option is if you have multiple servers that can that care about different problems. You can split your database, like with sharding or something, and your data can then be collocated to those specific workers. The normalization. This is something that you will encounter. It will allow you to have very fast queries because you will be avoiding using joins, which are expensive. On the flip side, you will have a data duplication, which sometimes is not a good thing.